If anybody is live, feel free to say hi. Welcome, welcome, everybody. I'll do roll at the end so that I don't, so we don't pause class. And then again, roll is only for people that are like in person permanently. And then if you're online but like joining for lecture, that's not a problem. The capacity is really only the lab, but I think we got that sorted out this morning. So if you're here, again, thank you. And hopefully we've added everything. And what else? Sorry, lost my train of thought. So yeah, you're always welcome to join the live lecture. So kind of the idea, like, I think you guys have gotten the picture that I'm trying to redo this course, make it a little better, because I do have a lot of students, right, that want to take it online or maybe want to pop in person. So I'm trying to make it a more like uniform experience. And so I did email out, I will say this then. So on that note, where are we in our notes here? I'll just start our announcement for today. So on that note, I did make a course announcement. So I'll say check Blackboard if you want to join my open math. And so I have like two thoughts with the my open math, and I'll explain it. So again, it's really just to help me in some ways. But some people express that like they prefer electronic homework, and if that's totally you, like that's fine. So here's an example of homework 1, and it's like the same question as you have on the paper version. So if you want to trial my open math, you can. The homework is also online, right? But it's just the paper format. So that's what I was saying. I was like trying to switch the class. But like I told y'all, apparently if your whole entire shell is not done in my open math, it doesn't copy well. So yeah, but I still would appreciate like people troubleshooting it. So the other issue is like I have to reprogram every question by hand in my open math. And like that'll save me time much later down the road, but right now it's obviously taking a lot of time. So that's why I'm going to give extra credit, or not like extra credit, but I said I was going to rejigger the percentages, and I explained that. So if you do help me with my open math, of course you'll get credit for like the homework and the quizzes, because again, they will be the same. So, right, like if you're in person and you're like, I just want to take these online quizzes, that's cool, then you don't have to take the paper quiz. If you're on Blackboard and online, like the Blackboard quiz is the same, right? So just take one quiz is what I'm saying, right? So like, let's just make this clear. So every week, all I need from you is homework, quiz, and then your lab. And of course, the lab is not in my open math. I haven't quite figured out how to make the lab at home better because I don't like the videos, but I mean, that's another story. But again, I would appreciate it. And then I said, if you do the extra work of doing this, then I'll drop the the exams to 40% of the grade, and then you'll get an extra like 10%. I'm not really calling it a bonus, but just like a helping bonus for like willing to try this. But if you're like, I don't even want to deal with this, don't worry about it. Yeah. Did I not put it? Okay, yeah. I didn't want to start like putting it on the internet because this is streaming to YouTube, and then I'm already having a crazy time trying to keep track of y'all. Oh, and then the other announcement I'll make. So I still haven't gone through my rosters. I'm hoping to do that tonight once hopefully the dust has settled. But make sure that you are enrolled in at least one lecture and one lab for Chem 104, right? You need both. At this point, I don't really care, what you're registered for as long as you have one lecture, one lab, right? You can tell me, hey, I'm showing up here and there. We'll figure out your grade. That's not a big deal. But just make sure that you are officially enrolled in the lecture and the lab to get your complete Chem 104 package there. All right, any other questions of like logistics and how the course is going? And again, this week's quiz is just a welcome quiz, so if you've done it online, great. Otherwise, my in-person people, right, I'm expecting y'all to take it today. Any other questions about... Oh, I did forget something on Monday. So I mentioned that this class is open note. And then with that, you know, so you can have obviously textbook resources, everything. So again, that's to like level the playing field. I don't, you know, online, I won't even go into like lockdown browsers and all that disaster that can always be. So that's why I have just open notes, level playing field. And then I also like to hand out these nice periodic tables, and I had some fun colors. So feel free to grab one of those. So you probably want a periodic table. We at least have one in the back now. But yeah, feel free to grab one of those, and I'm happy to make more periodic tables. And then if you're online and ever wanted to stop by and grab a periodic table or any other resources, that's fine. All right, so let's continue on. So quick recap. So Monday we had gotten as far as just kind of writing these conversion factors. Oh, and that's something that I did update on Blackboard. So Blackboard under the chapter 1 week, there should be an updated live link so you can see these notes live and update and all that good thing. And so hopefully we have our conversion factors. And again, these are just our relationships, right? Like we said, okay, there's 12 inches in a foot, or 1 foot and 12 inches. But now today, so we want to practice using our conversion factors. And so let's do the first one together. And okay, so it says convert the following. So 5 meters to kilometers. And the whole point of this is, okay, so now we can look at our cheat sheet over here. And so remember, meters is our base unit, okay? And then we can go to kilometers. And then, right, we have our conversion factor. Okay, well, there's 1 times 10 to the 3rd meters and 1 kilometer, or vice versa. And I'll just kind of put that to the side, right, like our appropriate conversion factor. So 1,000 meters equals 1 kilometer. And then some people were asking, and you know, people usually have this question of like, well, which fraction do we pick? But it all depends, right, which way we're going. So we're going 5 meters, and I'm going to write it in this like railroad track style. And then you want kilometers. So you want the unit that you're desired to be on top of your fraction. So that case, right, 1 kilometers goes on bottom, or excuse me, on top, 1,000 meters on bottom. And so you can see how meters cancels, right, if you do the division. And then it leaves us with the unit of kilometers. And then you can do either a little bit of mental math, or do you have a calculator handy? So again, I would kind of, you know, test your mental math skills. Okay, move your decimal over 1, 2, 3, or again, just make sure that you're using the calculator that you are comfortable with. And so we should get the answer of 0.005 kilometers there. And then if you're super bored, again, I apologize, just kind of bear with us, right? Again, we have to start somewhere, and I'm assuming that everyone has baseline 0 knowledge, so. All right, so see if you can try kind of the next ones then, or at least these first 2. So see if you can try those for a little bit. Yeah. So yeah, with the My Open Math, like if you do it, like so that's how it's set up. Is like the homework is just supposed to give you extra practice, and that's why it's taking me so long to program because I'm trying to make it like really, really random as opposed to Blackboard where people just create like a pool with 4 randomized tests. It's like I want it to be able to spit out any variable, but yeah. Anyways, that being aside, you can mix and match whatever. Like any feedback will help me, and I will appreciate it. So what do we get for this first one? Did we get an answer? Are we still kind of working? So what conversion factor do we want to use? So 3,000 milligrams. So let's go through it. So great 3 grams. And then you probably use, so there are 1,000 milligrams in a gram. And again, right, go back to your sheet. So you have milli, right? Okay, so same thing analogously, right? 1,000 millimeters in 1 meter, so 1,000 milligrams in a gram. So there's your conversion factor where we pulled it from. And again, grams on bottom. And then we're there. So then grams canceled, and then 3,000, just like you said. Questions on that one? So let's try the next one. So 7 meters to centimeters. So what's our conversion factor? So 100 what? So 100 centimeters in a meter. Excellent. So then we can set up our railroad track here. And then okay, so how I wrote it was correct. I didn't intend to. But right, centimeters on top, meters on bottom so that it cancels. Cancel, cancel. And then what do we get for our final answer? Excellent. 700 centimeters. Any questions? Again, ask questions, right? Now's your time to ask questions. Otherwise, I'll just keep speeding along, which If there are a few complaints about me as an instructor, but I would say that's like the one criticism that people have about me is that I'll just get overexcited and like start flying along. So that's why I'm always like, feel free to flag me down and tell me that you're confused, because again, I won't know you're confused, and I've taught this course 10,000 times, right? So. All right, let's try this next one. So it's a little bit trickier. I'm not going to reveal everything yet, but just kind of think about this for a second. So we're trying to go from milligrams to kilograms. So how could you approach this? And I'll give a hint. There's probably like two main ways to do this, and we'll go over like the two methods. But yeah, we'll give people like another minute or two to kind of sit. So what are our thoughts on this one? How could we approach it? Excellent. So that's, I think, like the easiest way to do it. And so I kind of call these like a two-step conversion. And then that's the other thing is I always like kind of say, it's like, okay, your base unit is your safe space, right? Like we have all our conversion factors in relationship to the base unit. So exactly, when we see something like that, that's I think the easiest way to do it. Because otherwise, like the other thing that you can do, well, let's do this and then I'll explain the other method, but I don't want to confuse people. But some people, it just depends on how everyone processes. So let's do that. So we'll go 60 milligrams. And so we'll go 2 grams, like you said. So gram on top. So there's 1,000 milligrams in a gram. And then we have to go to kilograms. So gram on bottom. And then, well, there's 1,000 grams in a kilogram. And so now we can either do mental math or plug it into our calculator. So I'll plug it into the calculator. So divided by 1,000, divided by 1,000. So we should have 6 times 10 to the negative fifth kilograms. And so the other method that you could use is just to derive like a new conversion factor. And so some people are like really good at that, but again, other people are not. It just depends like how mathematically inclined you happen to be, and I'm sure how long you've been practicing. And so looking at this case, right, we're going, so milligrams, if we go back to our cheat sheet, so milli, right, 10 to the negative third, and then kilo, 10 to the third. And so you could, right, like divide these units. So that would be one way to find their direct relationship. So 1 times 10 to the third divided by 1 times 10 to the negative third. and then you would get a factor of 1 times 10 to the 6, right? Difference between them. So basically, and I'll just kind of put alt method. So right, basically get our new conversion factor. And then, right, there should be many tiny units in the big unit. So that's 1 times 10 to the 6 milligrams is equal to 1 kilogram, right? And then now we can just do a direct conversion. And then, of course, you'll see we get the same answer. But again, right, if this is confusing to you, like, don't worry about it. I would, again, stick to kind of the two-step conversion. You know, that's kind of easier, one step at a time. Again, always to your base unit as kind of your safe home base. All right, so let's try. I'll give y'all maybe at least like 5 minutes. Let's see if we can do the rest of these. So just kind of work them on your own for a little bit. And then, of course, we'll go over them. But, right, ask me if you're having any issues. We can go over them, kind of point you in the correct direction, right? Ask your neighbor too, and then we'll go over them in about 5 minutes or so. All right, let's see how we're doing. So we got 2.5 meters to millimeters. So let's see, so 2.5 meters. So there's 1,000 millimeters in 1 meter. So then what do we get for our answer here? So 2,500 millimeters. Excellent. Questions on that one? All right, next one. So then we have kind of one of these potentially trickier ones, right? Centimeters to kilometers. We could do, right, the direct conversion. So it looks like there's a 10 to the 5th difference. But I'll work it out the two-step way. So let's go, we'll go centimeters to meters. So there's 100 centimeters in a meter. Okay, so now we're at meters. I want kilometers. So there's 1,000 meters in a kilometer. But then you can see that 10 to the 5th factor, right, come out. So maybe as you kind of work through them, you'll kind of feel better about that one-step direct conversion. And then, oh, well, I guess I don't need to plug this into my calculator. So now I have 4.5 times 10 to the negative 5th kilometers there. Any questions on this one? I don't know how far we got either, just time-wise. All right, let's look at this next one. So now we have 77 meters to decimeters. And so we have, right, there's 10 decimeters in 1 meter. So then our conversion factor. So I want, so there's 10 in 1 meter. So again, units cancel. So what do we get for our answer? So 770 decimeters. Excellent. Not too bad. All right, another potentially tricky one, right? So again, you can try to get the direct conversion factor or go decimeters to meters to millimeters. So let's see, let's do it. We'll do it the long way just for good measure. So 37 decimeters, right? We have our conversion factor. And so let's go 1 meter is 10 decimeters. Okay, so now we're in meters. And now we need to go back to millimeters. And so there's 1,000 millimeters in 1 meter. So units cancel. Okay, looks good, right? Leaving us with millimeters. And so then, right, if this factor wasn't apparent before, so deci, right, 10 to the negative 1, millimeter 10 to the negative 3. So we do see that difference of 100 between them, right? And you can see that, okay, 0 cancels 0, so that gives you 100. But again, don't expect you to jump there. And so then, let's see, so then we just have to add 2 zeros to it, so 3,700 millimeters there. So I could plug it into the calculator. So you could see the 10. So what one thing that you could do, so you could do 10 to the power of negative 1 divided by 10, to the power of negative 3. and then that gives you the 100 difference between them. And then it's always small units in the big one. So then that gives you, right, 100 millimeters is 1 decimeter for direct conversion factor. But like I said, if this is confusing and, or like, I don't know, my brain works like differently for some reason. Like sometimes like millimeters and kilograms, like that's fine, but the decimeter to millimeter, that seems a little more confusing, like even to my brain. So that's where like the two-step is always the way to go if you're like even a little unsure, right? So then you go decimeters to meters, and then back from meters to millimeters. Did that answer your question? I don't know. Okay, just making sure there. Other questions on this one? And then last one, so this is, again, another one where we could do the two-step conversion. And then again, in my brain, and it's probably just because like you see the ruler, right? So it's easy to go, well, I can make a direct conversion factor. There's 10 millimeters, right, and 1 centimeter. You could see that mathematically, so 10 to the minus 2 compared to 10 to the negative 3. And again, you want the tiny units in the big one, so more tiny units. And so let's convert this. And so then we can just move the decimal over. Did I go the wrong way on that? Oh, no. Yeah, so 0.02 millimeters. Sorry, I was saying meters for a second. I had a brain fart. So yeah, 0.02 millimeters there. And then that's the other thing. So kind of sanity check yourself. So when I sanity checked myself mentally, I did it wrong. But right, okay, so we're going from bigger units to smaller units. So yeah, it should get bigger, right, our number. Same thing like when we went up here, big units, small units, so we should have, right, larger number. But then when we go vice versa, like milligrams to kilograms, so tiny units to big units, right, should get very small. So just like kind of always sanity check yourself. Like, does it make sense? Am I going in the right direction? You know, does the order of magnitude look okay? That sort of thing. And just kind of doing those little mental checks will really help you. All right, other questions about converting or anything? Are we feeling okay about metric conversion? Okay, hopefully I see either nods or silence, so I hope the silence means we're on board. But like I said, if you need help, like ask me, and then we're going to end lecture in about 10 minutes anyways, right? Because like I said, Wednesdays, the other half is reserved for recitation, right? So that's your time to ask questions, get help, take the quiz. So obviously today there might not be too much, but I'm saying like, you know, if you need help, stay and get the help. Like that is your time, right? So use it wisely. Again, you know, the first week, enjoy it, but yeah, that's what the time is built in for, just individual practice, just working and me being available there. And then of course I have office hours after, but I just like tend to stick around for as long as people hang out. So if everybody disappears, that means that I'll probably like disappear unless you send me a message, right? So that's the other thing. I'm available like really anytime. I'm happy to work around your schedules. Catching me during like lab and recitation is always a good way. So that's why I'm like, use your lab time wisely, use your recitation time wisely. Otherwise, just email me. We can make an appointment and go over anything. Or, like I said, send me screenshots, send me pictures, send me email questions, right? If you're reading, if you run along a question, you look at the homework answer, you're like, this doesn't make sense. Just shoot me an email and we can get that clarified. All right, hopefully we can get through sig figs. We'll see how far we get. It's fine if we need to continue this kind of next week. And so you got a taste of this in lab today. And so like we were kind of learning in lab, so significant figures is just related to basically our measured values given in lab, right? So we saw in lab, okay, there's physical limitations, right? Our balance only goes so far. Our rulers only measure so much. Our glassware measures different volumes differently. And so, okay, we have to figure out how to treat these significant figures in our calculations. And so first of all, we start with, well, what's treated as exact? And so conversion factors are always treated as exact values, which just means you don't include them. So, right, you don't even think about them when determining how many sig figs for our calculations. And then, right, we just give examples. So again, just relationships. All right, so those don't count. Well, what are sig figs? Well, let's go through kind of these rules, and then again, we'll kind of talk about them, and it'll make more sense as we like practice, and then you go to lab and you see it physically, and then you kind of do it again. All right, so the first thing is, well, all non-zero values are significant. I think that's pretty self-explanatory, right? If it's a digit, it matters. So looking at this number here, right, 3 numbers written, 3 significant figures. And then the next rule is also kind of, I think, easy enough in that, and this is also called our captive zero. And so that is if we have a 0 between non-zero digits, then of course this 0 is significant. So then this number has 4 sig figs. All right, so now we get to what I call our magnitude zeros. And so these next 2 rules, we're going to see how these zeros just show either how big or how small. So on these leading zeros here, so it says that these are just placeholder zeros to the left of a non-zero digit are not significant. So this answer, 0.0043, only has 2 sig figs. And the rule and how I think about that is like these zeros are just showing how small, right? So they're just telling us, okay, what magnitude are we at? And so because it's showing how small, again, those are not significant. So they don't count towards your total number of sig figs and accuracy. And then same thing with our trailing zeros. So zeros to the right after a non-zero digit are not significant. So again, this shows how big. Now let's talk about this for a second. So there are a few scenarios, right? So let's look at 7,000 here. And so you kind of have to think about like, well, what are we measuring and what does this mean and how does this relate to the accuracy, right? And so let's say you were measuring, I don't know, a really large elephant, right? And so it's 7,000 kilograms or whatever. And so then the next question would be is like, how accurate is that balance, right? Because the way that it's shown here, we're saying that it's not accurate to these places, right? But what if your balance was accurate to this, right? And you wanted to show it and it reported all the way to the 1 gram. How would you show that it measured 7,000 precisely? Well, yeah, a decimal point. So good. So you could put a decimal point at the end. So you could do 7,000 period. And so then that does show that, yes, this number is significant. So then how this is written has 4 sig figs. And then, maybe we were using a scale that's only accurate to the tens place here. And so we could rewrite this the other way to do this is rewrite this in our scientific notation. So then we can do 7.00 times 10 to the third. Sorry, just don't want to mess that up. 1, 2, 3. And so this shows, right, okay, it's accurate to this digit, to the tens place, but not to this one, right? And then that's telling us that we have 3 sig figs for that measurement. And again, right, so you could rewrite it. So let's say you wanted to only give it 2 sig figs, so 7.0 times 10 to the third. And again, however many decimals you put in the scientific notation shows you the sig figs as well, right? So just to be clear, if we write 7 times 10 to the third, well, that's still just 1 sig fig, right? But then we could go 7.000 times 10 to the third, and now we're back at 4 sig figs again. So does that, yeah. No, the decimal point is just like there, right? And then when we put these zeros after the decimal point, these zeros are significant because we bother to put them in after. And so that was the last little rule that we had skipped up here, was that zeros to the right after a decimal point are significant. So again, now this is showing accuracy, right? So we didn't need to put this 0 on the tens place, right? Because we already had 50. But that 0 there is saying, no, we measured accurately to the 10th place. So we have 3 sig figs in this number. So same thing with this number. So this first 0, right, is a leading 0. So this is showing how small. But then these other 2 are showing accuracy. But that's always where, if you can like rewrite it in scientific notation, right, and then keep the decimals, so that shows, again, accuracy versus, right, decimals that are just showing how big or how small. Oh, we're kind of running out of time. All right, so last little bit, again, I think we saw this in lab, right? So we were practicing measuring to the meniscus and then estimating 1 pass. So again, I think we got this in lab, but just for clarity's sake. So 4 point, right, we're right between the 5 and the 6. So okay, it's 4.5, and then we have to take a guess, right, on that last digit. So that last digit is uncertain. They put 6. I mean, you know, I might put closer to 8 or 7. I mean, it doesn't matter, right? We can argue all day about it. So again, that's our uncertain digit and what we estimated pass. And then, right, we have 3 sig figs, though, for our measurement. All right. We might come back to this because I do want to give you a preview of your mathematical operations so you can like do the lab. So for doing the math and kind of the where it matters part, so for multiplication and division, this is kind of easier, I think, because the rule for this is the least precise measured value determines the number of sig figs, right? So whatever your lowest sig fig is, that's the answer. So when you're doing your calculations from lab, like if you have a volume difference that only has 2 sig figs, right, that's all you can report like your density to, for example. And then subtraction, addition, subtraction isn't too much harder. The only thing that I kind of say is like maybe you should write it in like elementary school style so you can clearly see after the decimal point, because it's the value with the smallest decimal that determines your sig fig. And so let's just kind of glance at these examples. So we have 3.56 times 4, and then right, just 1 sig fig. So I don't like this answer. And so this is kind of a reminder too of like make sure that you record enough information in lab, right? So if you're in lab and you had measured 4 centimeters precisely, well, you really should have written down 4.00, right, on your paper so that, okay, I have the 3 sig figs. Otherwise, we're saying, well, we only measured it to, barely 1 significant figure accurately. So I don't know what we're using to kind of estimate this, but this is way too few sig figs. So then when you punch it into your calculator and get 14.24, well, now you have to round down to 1 sig fig, which to me that feels really awkward to round this 14 to 10, but that's what's technically appropriate. So again, just give yourself sig figs. And then, so this is again a good example of the scientific notation. So our least precise has 2 after, so we can only report to 2 after, right? So that's why I said kind of elementary school style, so you can see it. And then, well, now we need to round to the 100th there. And then same thing, so I feel awkward about this one. So we didn't give it any numbers after the decimal place here, so we can't report to any after. So do the subtraction, and then we have to round all the way to 456. So again, just make sure you give yourself sig figs. All right, I'm probably going to end here today because, like I said, I want to kind of respect the time structure and what we've had. And so again, I want to show the format. So this is typically how we're going to do it. So we'll finish up next week. We don't have too much left. Just a little bit of the temperature conversions. So we'll go over this and do the quick calculations on Monday there. And then, so now would normally be a time, right, I would give a break and you can go do your thing. I'm going to go ahead and hand out the quiz because, like I said, it's just a really quick welcome quiz, like what are you doing here? Summer plans, how can I be a better instructor type of thing, which is, again, the exact same thing that's online. I'm just going to hand out a paper copy to everybody. And then you're free to take a break. And then, like I said, use this time wisely. So if you have questions on the conversions and anything, right, I would stick around and ask, or if you have anything on your lab, ask me now. But otherwise, you are free to go then. So I'm not here to hold you hostage.
We don't need this if we're doing the My Open Math.
Well, that's just a welcome quiz. You should still take it because that's not the My Open Math quiz is for the content. I didn't do a welcome quiz on My Open Math. But yeah, just quickly fill this out. Like, I don't care if you just put like requirement. I just want something. Oh, and while y'all are doing that, so I'm going to mute the stream. Take attendance real quick.